Alright, my dear, so this is a very crucial tutorial if you wanted to learn about heat exchanger. In short, it is known as HE, heat exchanger. So I was thinking why not to provide you some basic information about fixed heat exchanger. Well, I have already shared with you a couple of videos related to heat and mass transfer. So one of my student already asked me, sir, provide some basic approach to topic. So I have started providing basic approach. That's why this video is for you. Okay, so as you know, what is basically heat exchanger? So if you will say technically, then it is a steady flow open system device, you can say, right? Steady flow open system. Yeah, I need to share with you because based on this concept we have a very good numerical approach. Steady flow open system. So basically, what is the main purpose or objective of heat exchanger? To transfer heat from one body or one place to another place. That is the main purpose, and we utilize heat in that way. Suppose that we use heat exchanger in water cooler, air preheater, superheater, and even economizer. And we use economizer to uh, to hot or must say to increase the temp to must say temperature the increase the temperature of water. That's why it would help to use flue gases for increase the temperature of water. It will increase the efficiency of the power plant even. Okay, so this is all about heat exchanger. Okay, now most important, if I will talk about classification, then there are many ways to classify heat exchanger. Many ways, just like direct contact heat exchanger, direct contact heat exchanger. And if we'll ask example of direct contact heat exchanger, then I must say cooling tower. So basically what happened in case of direct contact heat exchanger, we allow hot fluid and cold fluid both mix up. We allow it that hot fluid and cold fluid can be mixed and then exchange heat because of temperature difference, because heat exchange only can take place if there is temperature difference between two bodies or two places. Alright, now next one is indirect contact heat exchanger. Indirect contact heat exchanger. So what is it? Indirect contact heat exchanger, that means it will not allow to contact hot fluid and cold fluid directly, I mean mix up. There is a gap. Suppose that hot fluid is flowing here and must be cold fluid, and there would be a separating wall. That's why both the fluid will not mix up. This is known as indirect contact heat exchanger. Now another example which is most important as well as crucial, that is regenerative type or maybe storage type. Somebody said storage type or regenerative type heat exchanger. Let me share with you a diagram, that's why you can understand about it properly. Hot and cold. Suppose that hot fluid entering here and cold fluid is entering here, and cold fluid is outing here and hot fluid is outing here. What happened in this type of heat exchanger? We exchange heat. First we have flowed one of the fluid at a time, and then we flowed the other fluid. That's why what will happen, in this way we exchange heat from hot fluid to cold fluid. And you know what happened here, all these are matrices, and these matrices are of cellulose matrix. this is a cellulose matrix, and this is how it exchange heat. Other than this, we have also rotating matrix type of regenerative heat exchanger, but I'm not going to share with you that because I have few more types of heat exchanger. Those are most important for competitive examination. That's why I will share with you all those types. According to flow, there are three types of heat exchanger. First one is parallel flow, second is counter flow, and third one is parallel flow, counter flow, and third one is, you know, that cross flow. And let me share with you, my dear, if you are preparing for competitive examination, if they will ask question from here, they will ask only application. Most of the time we have seen this, but if they will ask numerical, then they will ask from these two only, parallel flow and counter flow. And most of the time they ask question LMTD. You need to find out LMTD. Once you will come to know all these things, you can do much better in the competitive examination. Well, one of the most basic question they ask, which right now I am going to share with you. Hope you will understand, and not hope, you will definitely understand. I will share with you in that way. That's why you can understand about the question. Right now, let's go for that. Have you ever think what will happen if first law of thermodynamics applied to heat exchanger? Because as I have already shared with you, this is a steady flow open system. Then what will happen if I apply first law of thermodynamics to heat exchanger? Then change in enthalpy is equal to 0, and because net change in enthalpy of heat exchanger is 0, then we can say enthalpy change of hot fluid plus enthalpy change of cold fluid is equal to 0. Simple. As we can also say this, delta hot fluid is equal to cold fluid. We can also write this, right? Now, rate of enthalpy decrease of hot fluid and rate of enthalpy increase of cold fluid. Based on this, we usually get a question in the competitive examination. I hope you wanted to know that, right? So basically what happened, suppose that we have given a question, okay, we have space here. I can share with you some interesting fact. Suppose that we have given a question that there is a pot, and in this pot temperature of water is 20 degrees centigrade, okay, and here we have a rod. This is a steel rod and its temperature is 120 degrees centigrade. Okay, if we will put this rod into this water, then what will happen? What would be temperature of water after some time? 2 minutes, 3 minutes, 5 minutes, that would be depend on the question. So if you will see this type of question, then remember, this is just a gift for you, because I am going to share with you a tip. That's why you can solve this type of question quite easily. Suppose that if they will say with you rate of heat transfer is Q joule per second, okay, Q joule per second, that means watt, and they will ask you what will happen after 2 minutes. Then you must multiply this Q into 2 minutes to find out into joule per second. Okay, you have to convert into per second first. Second thing, which formula you need to use? The simple formula Q is equal to mc delta T. From here, mc delta T is equal to mc delta T. This is for steel and this is for water. Use both the formula, they will definitely give you mass, specific heat, change in temperature and change in temperature. So you need to find out its change in temperature. Okay, it's change in temperature, and definitely you can find out it. Okay, so this is how you can find out. And one more thing I have already shared with you, this minus sign will work here. will work here, this minus sign will work here. For steel, we have to multiply the minus sign, then it will happen T1 minus T2, and here T2 minus T1. This is how we can find out temperature, what will be the temperature of this water after 2 minutes or 5 minutes. That would be depend on question. I hope you understand the most basic concept of heat exchanger and some numerical approach to solve numerical problems. Practical approach, I must say that. Okay, thanks for watching. See you soon in my next video. Bye bye.